Welcome to 2.1, Solving Systems by Graphing. Today we're going to look at how to solve a system of equations by graphing, and then also how to determine the number of solutions without graphing. So a solution to the system is just a set of values that makes both equations true, or as many equations as are true. When we look at graphing, we want to look at where the lines intersect. That's the big thing there. So first, if we just want to determine if something is a solution, that means it's going to make both of these equations true. So all we're going to do is plug in, here's an x, here's a y. We're just going to plug that into these equations to see if it works. So 3 times 4 plus 3 times 1, does that equal 15? And that's 12 plus 3, which, yes, is 15. So it works in that one. Let's try our second equation. So negative 2 times 4 plus 3 times 1, does that equal negative 5? So negative 2 times 4 is negative 8 plus 3. And yes, that does equal negative 5. Okay, so this is our answer to this would be yes, this is a solution, because it makes both equations true. That x and y value, when we plug it in, satisfies both equations. Okay, so let's look into now if we want to solve this equation by graphing. We're going to graph both of these lines. So this first one, y equals negative x plus 3, that tells me my slope is negative 1 and my y-intercept is 0, 3. So I'm going to graph starting with 0, 3. And then a slope of negative 1 just tells me I go down 1 and over 1 from there. Okay. And so my line's going to look something like that. When you graph, you should be using a straight edge, so yours should be more exact than mine is. Second equation, I have m is 3 over 2, and my y-intercept is 0, negative 2. So I'm going to use that to graph. I'm going to start at 0, negative 2, then I'm going to go up 3 over 2. Okay, and so there's my graph for that one. And as you can see, this point right here is what they have in common, and that is 2, 1. So that is my solution to this equation. Okay, next, here's another example. What you notice though is that these lines are not in slope-intercept form. So we can choose to write them in slope-intercept form, or you can use intercepts to graph them. So that's what I'm going to do for this one. So this first one, I would just get 2x equals 12, so x equals 6. So I can plot the point 6, 0. And then 4y equals 12, so y equals 3. So I can plot the point 0, 3. Okay. And I can connect those dots. Again, you should be using a straight edge, so your lines should be more exact than mine. Second one, I just get x equals 2, so I'm graphing 2, 0. And then y equals 2, so I'm graphing 0, 2. So they are going to intersect over there about. This looks like my intersection point, so that is negative 2, positive 4. Okay, so then let's look at the different types of solutions that we have. If we're going to classify these systems of equations just based on their graph, this first one is intersecting lines. right? Which means that there is one solution. And we know that because the lines have different slopes and different y-intercepts, right? That gives us just one solution. If I look at this second picture, it looks like just one line, but if you'll notice, it's actually purple, which is telling us that that is two lines, both the red and the blue line, but they're overlapping. So that is actually the same line, which means that there are infinitely many solutions. Okay, and we identify that because they have the same slope and the same y-intercept, right? They're the same line. Okay, and then lastly, we have parallel lines. So again, you can see here, they do not touch. The definition of parallel is they don't touch, so there's no solution. Okay, and how we can identify that is that they have the same slope. You know that from Unit 1, but they have different y-intercepts. So they aren't the same line, but they still won't intersect, so there's no solution. So let's look at examples of how we identify that. Okay, so I'm going to start by getting both of these lines into slope-intercept form. So I'm going to take this first one and I'm going to solve for y. So subtract 2x. I get negative 4y equals negative 2x plus 8. And then divide by negative 4. So I get y equals 1/2 x minus 2. That's my first equation. So that gives me that my slope is 1/2 and my y-intercept is 0, negative 2. This one over here is already in slope-intercept form. So my slope is 1/2 and my y-intercept is 0, negative 4. So if we notice, the slopes are the same, the y-intercepts are different, so that means these lines are parallel, which means that there is no solution. These lines will never touch, so there is no solution to this system of equations. Okay, here's another example. We have y equals 2x minus 3, and then 6x minus 3y equals 9. So if we just start with this first one, that is in slope-intercept form. So my slope is 2, and my y-intercept is 0, negative 3. Second one, I'm going to put this into slope-intercept form. So I'm going to start by subtracting 6x from both sides. I get negative 3y equals negative 6x plus 9. Divide everything by negative 3. So I get y equals 2x minus 3. And if we look at that, that tells me that my slope is 2 and my y-intercept is 0, negative 3. So same slope, same y-intercept. That means it's the same line. So there are infinitely many solutions. If you looked at an example where they had different slopes, then your answer would be that they're intersecting lines and they would only have one solution. Okay, so that wraps it up for 2.1, solving systems by graphing.